Hello, Mr. Lee here. All right, let's solve for an angle in right triangles. Um, so this should be similar to the last video if you saw it for solving side lengths. We're going to use the same three equations here. These are your basic trig ratios: sine, cosine, tangent. But instead of solving for a side, we're going to solve for an angle. Okay, but it stems from these same equations actually. All right, so let's look at this problem. We want to solve for angle B. So the angle measure of B, which is going to be this labeled by this question mark. And we can label the sides of this triangle based off this reference angle, right? If we're trying to solve for an angle, that should be our reference angle, okay? So there's three possible sides: opposite, hypotenuse, or adjacent. Okay, so I like to start with the hypotenuse always. The right angle should always be identified, and then you go across the other side. Let me use a different color here. Go across the other side, you get the hypotenuse, right? Now I go to my reference angle, I go across the other side, that's the opposite side. And then the remaining side is the adjacent. Okay? So let's look at what we have. We know what the hypotenuse is, it's 9. And we also know what the adjacent side is, it's 5. We don't know anything about the opposite. So the equation that we want to use has to involve the hypotenuse and the adjacent side. So the only one that works is going to be the cosine. All right, that's how we choose which equation to use. And let's fill in the blanks. We're trying to solve for the angle measure, so we're going to leave that as theta. Theta is your Greek letter, often used for angles. So cosine of theta equals the adjacent over hypotenuse. The adjacent is 5, the hypotenuse is 9. All right? So we were able to fill in 2 of the unknowns out of the 3, so we can now solve the equation. Okay? So remember, we're solving for theta. This is just like x. If it helps you, you can use x, or you can put the question mark. Okay? Let's just leave it as theta for now. Okay? But we're solving for theta. Right now, the operation that's being done is a cosine of theta equals 5/9. I'm trying to get this, right? I'm trying to get theta equals something. Right? So how do you undo a cosine theta? You have to take the inverse cosine. Okay, so if I do inverse cosine of the cosine of theta, let me kind of skip around here, that's going to actually spit back out your original theta, right? It's just like inverse operations. You do the inverse cosine of a cosine, you're going to get back the original number, which is, in this case, it's the angle. Okay? So if you do the inverse cosine on one side, it's like any other operation on an equation. You have to balance it out. You also have to do it to the other side. So on the right side, it's going to become the inverse cosine of 5/9. Okay, so that's what it looks like. Inverse cosine of both sides. Now we have theta all by itself, right? So I can actually edit this, okay? So inverse cosine of cosine just gives me back theta. So there we go. Right, inverse cosine of 5/9. Calculator will do the work for you, 56.25. We want to round to the nearest hundredth. So 56.25. Hundredth is 2 decimal places. So let's see if that's right. Good. Let's do maybe 1 or 2 more. I'm going to clear this guy. All right, we're going to solve for angle A now. So kind of the same position, but different lettering. Angle A is over here. We do have some different known information, though. Okay, so let's go back to our labeling. I always like to start with the right angle. Across from the right angle is the hypotenuse, and then across from your reference angle, right? Reference angle is over here. Across is going to be the opposite side, so that's 9. And the adjacent side is 3. Okay, so I like how we're doing this example. We're going to actually hit a tangent now. Okay, we don't know anything about the hypotenuse. We only know the opposite and the adjacent side. Opposite, adjacent. So that means we have to use our tangent ratio. Okay, so tangent of theta, we're leaving that as a variable because we don't know what it is. If you want to, you can use a question mark, you can use an x. Okay, tangent of theta is equal to the opposite side, which is 9, over the adjacent side, which is 3. Okay? You can simplify this if you want to. It's just going to be 3. 9 divided by 3 is 3. But I like, just as a habit, I like letting the calculator do the work at the very end. So I'm going to leave it as 9 over 3. Why not? Okay? But let's get practice understanding what happens next, right? Tangent of theta equals 9 over 3, right? You don't have theta by itself yet. You want it by itself like that. So to undo the tangent operation, we have to do the inverse tangent, right? Inverse tangent of the tangent of theta is going to spit back out your theta like that. Okay, so I'll simplify this later on, but inverse tangent of the left side is what we want to get theta by itself. So then we have to keep it balanced. Let's do the inverse tangent of the right side. So inverse tangent of 9 over 3. Okay, so I'm going to edit this now. I'm going to delete the tangents because the inverse tangent of a tangent gives you the original angle back, right? Which is just theta. Okay, so inverse tangent of 9 over 3, 71.565, round to the nearest hundredth. So this third decimal place 5 is going to shoot this 6 up to a 7, right? 71.57. There we go. I think we'll end it there. But like I said, you can pause these videos, take your time with it, and give the practice a try.